Welcome to week 21 of Math Calendar 2022. On this video presentation, we're going to show the answer and solution to our featured problem for week 21. Please subscribe and click the notification bell to be updated with our math problems and solutions on Math Calendar. Before we continue, let us appreciate and recognize those who participated and commented their answers to our featured problem. You may also suggest a math problem that you would like us to feature on Math Calendar. Here now is our featured problem for week 21. An architect wants to design a theater with 16 seats in the first row, 20 seats in the second row, 24 seats in the third row, and so on. If the theater is to have a seating capacity of 900, how many rows must the architect use in the design? Here is our suggested solution. Let A be the number of seats in a row, N be the number of rows, and S be the sum of the seats in the theater. In our problem, we're looking for the value of N. From the given information, we have 16 as the number of seats in the first row, then A sub 1 is equal to 16. On the second row, A sub 2, we have 20. And on the third row, we have 24 seats. Also, we are given the seating capacity. That means the total number of seats in the theater is 900. S sub n is equal to 900. In here, we have an arithmetic series. We can write the equation as the first term, 16. The second term, 20, 16 plus 20. The third term, 24, until the last term, let us call it A sub n. And the sum is equal to 900. For an arithmetic series, we can have the formula for the sum of the partial terms as S sub n is equal to n over 2 times the quantity 2a sub 1 plus n minus 1 times the closed quantity. In here, S sub n is the sum of the terms in the arithmetic series, n is the number of terms, a sub 1 is the first term, and d is the common difference. From our given information, we already have a sub 1, that is 16, S sub n, that is 900, and we're looking for the value of n, so we only need to identify the common difference, and that may be obtained by subtracting any term by its previous term. So we have 20 minus 16, or we can have 24 minus 20, then the common difference is equal to 4. This time, we can substitute the values to the given formula. Then we have S sub n is 900. So we have 900 is equal to n over 2 times the quantity. 2 times a sub 1, that is 16, plus open and close parenthesis, n minus 1, times the common difference, that is 4, close quantity. Let us multiply both sides of this equation by 2. We can have 1,800 is equal to n equals, inside the parenthesis, we have 2 times 16, that is 32. And distributive property, we have 4 times n, 4n, and 4 times negative 1, that is negative 4. Still, we can use the distributive property of multiplication. On the right-hand side, we'll have 1,800 is equal to 32n plus 4n squared minus 4n. And this time we can combine similar terms, we have 32n minus 4n. So we have 1,800 is equal to 28n plus 4n squared. The resulting equation is a quadratic equation. Next, we can write it in standard form. So we have 4n squared plus 28n minus 1,800 is equal to 0. We can simplify this resulting equation by dividing all terms by 4. So we have n squared plus 7n minus 450 equals 0. To solve this resulting quadratic equations, we're going to use solution by factoring. The left-hand side is a factorable trinomial. N squared plus 7n minus 450 can be factored as n minus 18 times n plus 25. Next, we're going to equate each factor to 0 and get the value of n. So we have n minus 18 equals 0 for the first factor, n plus 25 equals 0 for the second factor, and this is using the zero property of multiplication. From n minus 18 equals 0, we can have n is equal to 18, that is adding 18 to both sides of the equation. On the second equation, we have n plus 25 equals 0. Subtracting 25 from both sides of this equation, we'll have n is equal to negative 25. We know that n is the number of rows inside the theater, then n must be a positive integer. So for our solution, we have n is equal to 18. There are 18 rows inside the theater, and n equals negative 25 is an extraneous root of the resulting quadratic equation. That will be all. Thank you for watching. Tune in again on Sunday for another featured problem. Please subscribe for more of Math Calendar.